In 2016, NASA sent a spacecraft into one of the most dangerous places in our whole solar system. Scientists gave it less than 2 years to live. They built it with a thick metal shield, hoping it would survive just long enough to send back some data before it got fried. That was 10 years ago. The spacecraft is still out there right now, still flying, still working, long after everyone expected it to be dead. How did it survive something that should have destroyed it in months? And what did it find out there that turned everything scientists thought they knew about the biggest planet in our solar system completely upside down? This is the story of Juno. Stick around, because by the end you're going to hear about a hidden ocean, a planet with a secret jelly center, hail made of slush, and the biggest explosion ever caught on camera in our solar system. And somehow, this same little spacecraft is still out there today, flying past deadlines nobody thought it would ever reach. Let's get into it. Flying into a death trap. To understand why Juno's survival is such a big deal, you first need to understand where it was heading. Jupiter is the biggest planet in our solar system. It is so huge that you could fit more than 1,000 Earths inside it. But size is not the scary part. The scary part is what surrounds it. Jupiter has a radiation belt around it. Think of radiation like an invisible storm of tiny, fast-moving particles. This storm is so strong that it can rip through metal and destroy computer chips. It is one of the harshest environments any human-made object has ever tried to fly through. A NASA probe called Galileo flew through this radiation years before Juno, and the damage it took caused all sorts of problems during its mission. So when NASA planned Juno's trip, they had a big problem. To study Jupiter up close, Juno had to fly right past this deadly radiation. There was no way around it. Juno itself is a strange-looking spacecraft. It has 3 giant solar panels stretching out like wings, each one longer than a school bus. It needs panels that huge because sunlight out at Jupiter is much weaker than it is here on Earth. Only about 4% is strong. Even with all that surface area soaking up sunlight, Juno only makes a tiny amount of power, barely enough to run a couple of household appliances. Most spacecraft that travel this far from the sun use a different kind of power source instead of solar panels. So choosing to send a solar-powered spacecraft this deep into space was already a bold move before Juno even faced the radiation problem. NASA's engineers came up with a clever fix. They wrapped Juno's most important electronics in a box made of titanium, a super strong metal, about 1 centimeter thick. People joked that it was like sending a tiny armored tank into space. But even with this shield, nobody was sure it would be enough. The mission was planned to last less than 2 years in orbit, because that is about how long scientists thought Juno's instruments could survive the radiation before breaking down. Getting to Jupiter in the first place was its own challenge. Juno launched on August 5th, 2011. Instead of flying straight toward Jupiter, it did something surprising. It flew back toward Earth first. 2 years after launch, Juno swooped past our planet and used Earth's gravity like a giant slingshot. This trick sped Juno up by over 14,000 kilometers per hour without using barely any fuel. It is a smart way to save energy on a very long trip. Juno launched on top of a powerful rocket called an Atlas V. Within less than an hour after liftoff, it was already speeding away from Earth fast enough to escape our planet's gravity for good. That first hour is one of the riskiest parts of any space mission, since so many things could go wrong, but everything worked exactly as planned. After 5 years of travel and a journey of over 2 billion kilometers, Juno finally reached Jupiter in July 2016. It slipped into orbit and began flying in tight, stretched-out loops around the planet, swinging in extremely close and then swinging back out millions of kilometers away, over and over again. Each full loop took about 53 days to complete. Here's the part that really surprised everyone. Juno found a small gap between Jupiter's atmosphere and the worst part of the radiation belt. By threading through this narrow gap on every orbit, Juno managed to dodge most of the radiation that scientists feared would destroy it. The radiation it did take was 10 times weaker than expected. That lucky break is one of the biggest reasons Juno is still alive today. But surviving was only step 1. The real reason this mission matters is what Juno actually found once it got close enough to look. Before we get into that, if you're enjoying learning about this wild spacecraft, hit like and subscribe. Not because it is a nice thing to do, but because this channel breaks down real space missions like this one in a way that actually makes sense, without a ton of confusing jargon, so you can understand what is happening up there without needing a science degree. If that sounds good to you, subscribing means you will not miss the next one. Now, let's get to the strangest discovery Juno made, something that changed how scientists think about giant planets forever, the secret hiding at the center. For a long time, scientists argued about one simple question. What is inside Jupiter? There were 2 main ideas. Some scientists thought Jupiter had no solid center at all. They believed it was just gas all the way through, like a giant ball of swirling clouds with nothing solid in the middle. Other scientists disagreed. They thought Jupiter must have a hard, solid core buried deep inside, made of heavy materials like rock and metal, sort of like a giant marble sitting at the very center of the planet. Both ideas could not be true at the same time. Scientists needed a way to look inside Jupiter without actually cutting it open, which of course is impossible. So they came up with a clever trick using gravity. Here's the idea. Every planet pulls on nearby objects with gravity, but gravity is not perfectly even all over a planet. It changes slightly depending on how the mass inside the planet is arranged. If you can measure those tiny changes in gravity very precisely, you can figure out what is inside. Kind of like feeling the shape of something wrapped inside a blanket without unwrapping it. Juno was built to do exactly that. As it flew close to Jupiter, the planet's gravity would speed Juno up, or slow it down by tiny amounts, sometimes by less than 1/100th of a millimeter per second. That is a change so small it is almost impossible to imagine, but Juno's instruments were sensitive enough to catch it. Here is how they actually measured it. Juno sent a steady radio signal back to Earth the whole time it flew past Jupiter. When Jupiter's gravity pulled Juno forward and sped it up, the radio signal changed pitch slightly, kind of like how an ambulance siren sounds higher as it drives towards you and lower as it drives away. By listening closely to these tiny pitch changes over and over again, on pass after pass, scientists on Earth slowly built up a detailed map of Jupiter's gravity, far more detailed than anything created by earlier missions. What they found in 2017 was not what anyone expected. Jupiter's core is not a hard, solid ball like a marble, but it is not just empty gas either. It is something in between. Scientists started calling it a fuzzy core. Instead of a clear boundary between a solid center and the gas around it, Jupiter's heavy material seems to blend slowly into the surrounding gas, with no sharp edge at all. And this fuzzy region is huge. It stretches out to about half of Jupiter's entire radius. Think of it like making soup. If you dump a bunch of vegetables into a pot and never stir them, the heaviest chunks sink straight to the bottom and stay separate from the broth. That is basically what scientists expected to find inside Jupiter, a heavy solid lump sitting at the bottom, separate from the gas around it. But what Juno actually found was more like a soup that had been stirred just enough to blend the heavy chunks partway into the broth, without ever fully mixing everything together, and without any clean separation between the two. Nobody expected that. This discovery broke both of the old theories. It also raised a brand new question. How does a planet end up with a fuzzy, blended center like that? One early guess was dramatic. Maybe Jupiter used to have a normal solid core, and a long time ago something smashed into it, a massive collision with another baby planet, shattering the solid core and mixing it into the surrounding gas. It is a great story, but when scientists tested this idea using powerful computer simulations, it did not hold up. Every time they simulated a giant collision, the heavy material would eventually settle back down and reform a solid center, kind of like sand settling to the bottom of a glass of water after you stir it. The fuzzy blend that Juno actually saw never showed up in these crash simulations, so scientists looked somewhere else for clues, and strangely, the next big hint came from a totally different planet, Saturn. Scientists studying Saturn's rings noticed tiny ripples in them caused by vibrations coming from deep inside Saturn itself. By studying these ripples along with gravity data, they realized Saturn also seems to have a fuzzy, blended core, very similar to what Juno found at Jupiter. That was a huge clue. If two giant planets both have fuzzy cores, it probably is not because of some random accident like a collision. It is more likely that fuzzy cores are just a normal part of how giant planets form in the first place. Scientists are still working out exactly how that happens, but Juno's discovery basically forced everyone to rewrite the story of how giant planets like Jupiter come to be. And here's the twist. You would think solving the mystery of Jupiter's core would help explain its other big mystery, its powerful magnetic field. Instead, it made that mystery even more confusing. To understand why, we need to talk about lightning, slushy hail, and some of the wildest storms ever recorded. Lightning, slushy hail, and the wildest storms ever seen. Jupiter has the strongest magnetic field of any planet in our solar system. It is so massive that if you could somehow see it in our night sky, it would look bigger than the full moon. This magnetic field comes from deep inside the planet, where extreme heat and pressure squeeze hydrogen so hard that it starts acting like liquid metal. As this liquid metal swirls around inside the fast-spinning planet, it creates electricity, and that electricity creates the magnetic field. Scientists hoped that once they understood Jupiter's fuzzy core, it would help explain some strange quirks in this magnetic field, like why it is much stronger in the north than in the south, or why the planet actually has two south magnetic poles instead of just one. Instead, the fuzzy core made things more confusing. When scientists tried building computer models using the fuzzy core, the magnetic field that came out did not match what Juno actually measured. Something else had to be going on deep inside Jupiter to explain the weird pattern, and right now, nobody knows exactly what that something is. While mapping out this magnetic field, Juno also spotted something scientists nicknamed the Great Blue Spot, a small area where the magnetic field is unusually concentrated, almost like a magnetic hotspot on the planet. By comparing Juno's readings with older data from earlier missions decades ago, scientists noticed something that had never been seen on any planet in our solar system before. Jupiter's magnetic field is slowly changing shape over time, and the changes show up most clearly right around that Great Blue Spot. One day on Jupiter lasts only about 10 hours, which is much shorter than a day here on Earth. That fast spin stirs up the liquid metal hydrogen deep inside the planet and helps power its enormous magnetic field. Interestingly, scientists actually use the spin of the magnetic field itself to measure exactly how long a day on Jupiter is, since the colorful bands and stripes you see on the surface move at different speeds and cannot be used to measure the planet's true rotation on their own. But even without a full answer, this powerful magnetic field creates one of the most beautiful things Juno has ever photographed, Jupiter's auroras. You have probably seen pictures of auroras on Earth, glowing green and purple lights near the north and south poles. On Earth, they only show up for a few months each year. On Jupiter, the auroras never stop. They are hundreds of times more powerful than anything we see on Earth, and they glow constantly at both poles. Juno carries a special camera that captures these auroras in incredible detail. The pictures show a bright glowing spot connected to Jupiter's moon Io, caused by Io's intense volcanic activity interacting with Jupiter's magnetic field. Fainter spots come from two other moons too, Europa and Ganymede, each leaving its own little fingerprint in the light show. Now here is where things get genuinely strange. Juno also solved a 40-year-old mystery about lightning on Jupiter. Back in 1979, a spacecraft called Voyager saw flashes of light in Jupiter's atmosphere that looked like lightning. Scientists assumed it worked just like lightning on Earth, deep down in the clouds where water exists as ice, liquid, and gas all at once. But when Juno looked closer using a special camera, it spotted lightning flashes happening much higher up in the atmosphere than anyone expected, in a spot far too cold for regular lightning storms like we have on Earth. So scientists came up with a new explanation, and it sounds like something from a science fiction movie. At that extreme cold, ammonia acts like a kind of antifreeze. It mixes with water to create a special slushy liquid that can stay wet even in temperatures far below zero. These strange storms create powerful lightning, and they rain down hail made of this ammonia and water slush. Scientists actually nicknamed this weird hail mushballs. Jupiter's storms do not stop there. Juno also gave scientists their best ever look at the Great Red Spot, a giant storm on Jupiter that has been raging for at least 400 years. Scientists already knew the storm was huge, wider than Earth itself. But Juno discovered the storm goes incredibly deep too, reaching farther down into the planet's atmosphere than any instrument on Juno could even measure. The Great Red Spot itself also turned out to be stranger than expected. Scientists already knew the storm has been raging for at least 400 years, and that it is wider than the entire Earth. But when Juno measured the temperature inside the storm, it found something odd. Close to the top, the storm is actually cooler than the air around it. But once you go down about 80 kilometers, it suddenly flips and becomes warmer than its surroundings instead. Scientists think this hidden warmth deep inside might be part of what keeps this centuries-old storm alive and spinning. And near Jupiter's poles, Juno found something nobody had ever properly seen before. Giant swirling storms arranged almost like a pattern. The North Pole has 8 of these massive storm systems circling around it, and the South Pole has 5. They have stayed fairly stable for years, spinning like clusters of hurricanes locked in a strange, steady dance, never quite merging together and never quite drifting apart. Juno's cameras also picked up smaller details hidden inside these storms, thanks to a special instrument that can peer beneath the visible clouds using different types of light. Some storms that look almost identical on the surface turn out to be built completely differently deep down, with some reaching much farther below the clouds than others. Jupiter itself turned out to be far weirder than anyone expected. But Juno was not just studying the planet. Eventually, its mission expanded to visit some of Jupiter's moons too, and what it found there might be even more shocking than anything on Jupiter itself. Visiting Jupiter's wild moons. Juno's original job was to study Jupiter, not its moons, but Juno turned out to be way tougher than expected. Its instruments barely showed any damage from the radiation, even years after they were supposed to fail. So instead of ending the mission early, NASA decided to squeeze even more value out of this incredible spacecraft. They sent Juno on close flybys of 3 of Jupiter's biggest moons, Ganymede, Europa, and Io. Ganymede is the largest moon in our entire solar system, even bigger than the planet Mercury. It is such a strange thought that a moon, something that is supposed to orbit a planet, could actually be bigger than a planet of its own. In June 2021, Juno flew within about 1,000 kilometers of its surface and snapped incredibly detailed photos. its closest look at Ganymede after an earlier, more distant flyby a couple years before. These images showed an icy surface covered in craters and long, strange lines stretching across the moon like scars. Scientists believe Ganymede hides something amazing beneath all that ice, a massive saltwater ocean buried under its frozen crust. Some of those long lines, scientists spotted, might be cracks caused by heat and movement deep inside the moon, possibly connected to a metal core at its center. It is still being studied, but the idea that an icy moon so far from the sun could be hiding a hidden ocean is honestly kind of incredible to think about. An even bigger surprise about Ganymede came from an entirely different telescope. Not Juno itself, but the Hubble Space Telescope. NASA asked Hubble to check Ganymede's thin atmosphere for oxygen, since scientists were pretty confident they would find plenty of it there. Instead, they found something totally different. Barely any oxygen at all, but a whole lot of water vapor. This unexpected result forced scientists to completely rethink what Ganymede's atmosphere is actually made of. Next, Juno turned its attention to Europa, one of the most talked about moons in our entire solar system when it comes to the search for alien life. In September 2022, Juno flew close enough to snap incredibly sharp pictures of Europa's icy surface, showing deep cracks, ridges, and shadowy craters in stunning detail. Like Ganymede, Europa is thought to hide a massive ocean underneath its icy shell, and many scientists consider it one of the best places in our solar system to search for life beyond Earth. Europa's icy shell is thought to be more than 10 kilometers thick in places, which is a lot of solid ice sitting between the surface and whatever ocean lies below. One especially interesting photo showed a strange, dark patch on Europa's surface. Scientists think this might be a spot where material erupted up from below the ice. A newer theory suggests Europa might have pockets of super salty water trapped inside its icy crust itself, sort of like underground lakes of extremely salty slush that occasionally swell up and burst through the surface ice. If that is true, it means Europa's hidden ocean might not be the only place worth exploring. There could be watery secrets much closer to the surface, too. A future mission is planned to investigate this even further, so this mystery is definitely not over yet. Finally, Juno turned toward the moon that might be the most dramatic of them all, Io. Io is the most volcanically active place in our entire solar system. It is covered with hundreds of volcanoes, some shooting molten lava dozens of kilometers into the sky. All this violent activity comes from something called tidal heating. Picture Io caught in a constant tug-of-war between Jupiter's massive gravity pulling on one side and the gravity of nearby moons pulling from the other. This constant stretching and squeezing generates enormous heat deep inside Io, and that heat has to escape somehow. It escapes as volcanoes, hundreds of them constantly erupting. Between 2023 and 2024, Juno flew closer to Io than any spacecraft ever had, capturing incredible images of glowing lava lakes, massive volcanic craters, and ghostly plumes rising above the horizon. One photo captured two separate volcanic plumes erupting at the same time. Another revealed a massive lava lake called Loki Patera, so smooth in places that it reflected light almost like a mirror. During these close flybys, Juno also caught a glimpse of one of Io's strangest landforms, a tall, jagged peak scientists named Steeple Mountain. It rises between 5 and 7 kilometers above Io's surface, shaped almost like a cathedral spire pointing up into the black sky. Standing at the base of a mountain like that, on a moon covered in erupting volcanoes, would probably feel like standing on another planet entirely, because in a way it is. Juno also spotted something else nobody had properly seen before, active volcanoes near Io's North Pole. Earlier missions had never captured clear images of this region, so finding volcanoes there for the first time helped scientists realize that Io's fiery activity is not just limited to certain areas. It might be happening almost everywhere across the moon, hinting that there could be a vast ocean of melted rock churning away somewhere beneath Io's entire crust, not just in a few isolated pockets. Then came the moment that shocked everyone watching. On December 27, 2024, as Juno flew past Io, dozens of volcanoes erupted at almost exactly the same time across a massive stretch of the moon's surface. It became the single most powerful volcanic event ever recorded anywhere in our solar system. Imagine watching dozens of separate eruptions light up at once, almost like the moon itself was having a fit. Scientists believe many of these volcanoes are connected underground through channels of molten rock, which is why so many of them erupted together in this incredible, fiery display. At this point, Juno had already gone far beyond anything anyone originally expected of it. It had outlived its planned lifespan by years. It had explored not just Jupiter, but 3 completely different moons in jaw-dropping detail. And yet, the most surprising part of this whole story was still to come. The spacecraft that refused to die, remember. At the very start, when scientists thought Juno would only survive for about 2 years in Jupiter's deadly radiation, Juno's official extended mission was supposed to finally wrap up in September 2025. That was the real final deadline. After years of bonus discoveries, this tough little spacecraft was finally supposed to be done, except it was not. Around the time its mission was supposed to end, something unrelated happened back on Earth. A shutdown in the United States government caused confusion about NASA's operations, and for a while nobody outside of NASA really knew what was happening with Juno. Some people even wondered if it had quietly been shut down without anyone announcing it, since that had technically been the original plan all along. Juno was eventually supposed to be steered into Jupiter's atmosphere on purpose, so it could never accidentally crash into one of Jupiter's moons that scientists hope to study for signs of life someday. But then, just recently, NASA posted an update about brand new data Juno had collected, helping scientists figure out how thick the icy shell covering Europa really is. Buried near the end of that update was one small but stunning detail. Juno was scheduled to complete its 81st flyby of Jupiter. Juno is still flying right now, long after everyone, including the scientists who built it, expected it to be gone. NASA even faced the possibility of budget cuts that could have shut missions like Juno down for good to save money. But those cuts did not happen. Juno's funding held on, and this remarkable spacecraft kept going. Think about that for a second. This is a spacecraft that flew through one of the harshest radiation zones in the entire solar system, a place strong enough to fry most electronics in a matter of months. It was given less than 2 years to live. Instead, it kept going for a decade, outlasting not just its original mission, but its extended mission too, and even a confusing shutdown that left people wondering if it had quietly been switched off without anyone noticing. Part of the reason NASA always planned to eventually crash Juno into Jupiter is actually about protecting the very moons it just spent years studying. Scientists believe Europa and Ganymede might have oceans capable of supporting some form of life. NASA does not want an old, uncontrolled spacecraft accidentally crashing into one of those moons someday and contaminating it. So when Juno's mission finally does end, it will most likely be steered on purpose straight down into Jupiter's thick clouds, burning up long before it could ever reach anything living. Nobody knows exactly how much longer Juno will last before that happens. But until that day comes, Juno keeps circling one of the most dangerous places in our entire solar system, sending back data, capturing photos, and quietly rewriting what we thought we knew about giant planets one flyby at a time. A spacecraft that was only ever expected to survive for 2 years just kept going and going and going, past every deadline anyone set for it. Somehow, 10 years after arriving in one of the deadliest environments in our solar system, it is still out there today, still working, still discovering. If that is not one of the toughest machines humans have ever built, it is hard to imagine what would be. Before you go, if you made it this far, you clearly love space as much as we do. Hit like, subscribe, and tap the notification bell so you never miss the next mission breakdown. So here's a question for the comments. Out of everything Juno found, the fuzzy core, the slushy mushball hail, or Io's massive eruption, which one shocked you the most? If you want more stories like this, check out our other videos on Jupiter's moons and NASA's most daring missions. Thanks for watching, and we will see you in the next one.